Welcome everybody to day 2 of your rigid motions unit. For today, you're going to be needing a calculator, a straight edge, a highlighter, and your note packet. Okay, as you get yourselves ready, our goal for today, given a reflection, you will be able to reflect a shape over a line and find the line of reflection. All right, so today everything is all about reflections. Now, I know you did reflections back in middle school. And a reflection is when you take a point and you project its image onto the opposite side of a line, making sure that you keep the distance the same. What's going to be new this year is that we are going to add in a new notation. So whenever we're talking about a reflection, we're going to use an undercase R, and then in subscript, written very small right underneath it, it's going to have the name of your line of reflection. All right, so let's go ahead. We're going to practice the notation first. So here we're going to reflect over line K, point A. So our line of reflection here is line K. So what I'm doing is I'm trying to reflect or project it to the opposite side of that line. So if I take point A and I want to flip it over line K, its image is going to become Y. Next up, if I take point B, that's in the parentheses, that's your pre-image, and you reflect it over, it's going to become X. And if you take point C and you reflect it over line K, well, wait a second, can you reflect it over line K or is it right on line K? If you fold it over, line C is not going to change. It's going to stay exactly the same. And in geometry, we like to call that invariant. It is not going to change. So that's going to be a new vocabulary word for us today. Invariant means it does not change. Okay, and then next we have a reflection over line K, angle ABC. So if we take an angle and we want to reflect it over, it's going to remain the angle, and it is going to be angle Y, X, and C. Okay, so taking a look at this picture, we have our pre-image. This is what we started with. And we projected it onto the other side, which became our image. So what properties have been preserved in this line reflection? So remember, we talked about things that were preserved in our lesson yesterday. So we talked about preserving. So we can preserve shape, distance, and angle measure. So if we look at those three, which ones have we preserved here? Well, have we preserved the shape? Yep. Have we preserved the distance, the side measures? Yep. And did we preserve the angle measures? Everything is the same. So we are going to preserve shape, side measure, and angle measure. And another thing that we are preserving that's very unique to reflections is we're preserving the distance away from your line of reflection. For instance, A to my line, if this is 1 centimeter, then it also has to be 1 centimeter on the opposite side. Okay, so what property is not being preserved in a line reflection? All right, and that is going to be orientation. Now think of it this way. When you look in a mirror in your bathroom, and if you raise your right hand, what does it look like in the mirror? It looks like your left hand. And that is because in a reflection, your orientation is reversed. So now on a sheet of paper, the way we can look at orientation is we're going to look at the order of the arrangement of your vertices. So if we take a look here, orientation refers to the arrangement of the points relative to one another after a transformation has occurred. So if we look here, we have a line of reflection. We took our image, our pre-image, and we reflected it over. But now if you look at the order of the letters, A goes to B, goes to C, which then goes back around to A. This is going in a counterclockwise fashion. Now if you look at your primes, we go A prime to B prime to C prime, which then goes back up to A prime. This is going in a clockwise. So they are going in opposite directions, which means they have opposite orientations. Okay, so now that we've gone over kind of the facts and the notation, let's learn how to reflect points over lines. Okay, so the first one we're going to do is we're going to learn how to reflect points over the y-axis. So let's take a look here. On our coordinate system, we have the x-axis, we have the y-axis. Now, another name for your x-axis, this is the equation y equals 0. And your y-axis is the equation x equals 0. Okay, so those can be used interchangeably. They mean the same thing. So now if we look at our notation, we are going to reflect, and in subscript here we have the y-axis. So I'm going to highlight my y-axis. This is my line of reflection. Okay, and we're going to reflect the point 3, negative 1. So I'm going to go over 3, down 1, and I'm going to name this point, point A. So now I want to reflect it to the other side of my line of reflection, so I'm going to flip it over. Now I have to make sure that I preserve distance. So if I count, I am 1, 2, I'm 3 units away. So its image should also be 3 units away. 1, 2, 3. And here is my A prime. So this becomes the point negative 3, comma, negative 1. Okay, let's try the next one. A reflection over the line x equals 0. Now remember, x equals 0 is the same thing as your y-axis. So we're going to reflect the point negative 4, 2. So negative 4 up 2. I'm going to name this point B. So I want to reflect or flip it to the other side. So this is going to be 1, 2, 3, 4 units away. So it also has to go 4 units away on the other side. B prime. And this becomes the point, so now instead of negative 4, it is positive 4, comma 2. Okay, so what we did here, this is called the counting method. So we just counted the spaces, and then we did the same number of spaces on the other side. But now if you look carefully at your points, we can kind of see exactly what's happening. When you reflect over the y value stays the same, but if you look at your x, we are negating the x value. So the x goes from positive to negative and from negative to positive. So if you are somebody that likes to follow a rule, you can memorize this rule, or you can always use the counting method, that x comma y changes to negative x comma y. And just as an FYI, the equation of the y-axis is x equals 0. All right, so let's go ahead now and let's try now reflecting over the x-axis. So here's our x-axis, which we also know is the equation y equals 0. So we are going to reflect over the x-axis. So I'm going to highlight my x-axis. This is my line of reflection. And we are going to reflect the point 3, negative 1. So I'm going to start by plotting 3, negative 1, and I'm going to name that point A. So now I'm going to count. I need to make sure I'm the same distance. So if I'm below the line, I need to go to above the line. I'm 1 away, so I have to go 1 away on the other side. Here is A prime, and it's becoming the point 3, comma 1. Now let's try our next example. Say a reflection over the line y equals 0, which is just a fancy way of saying the x-axis, the point negative 4, 2. Okay, so I want to flip it over that line of reflection. So if I look, I am 2 units away, which means I have to be 2 units away on the other side. So B prime, we are now at negative 4, negative 2. So what's happening to our points from start to finish? Well, we're taking the point x, y, and we're changing it. How are we changing it? Well, we're keeping the x the same, and we are negating the y value. And just as an FYI, the equation of the x-axis is y equals 0. All right, so next up, we are going to reflect over the line y equals 0. So let's take a look. If you don't remember what the line y equals 0 is, we're going to go to our calculators and type in y equals x, and we're going to hit graph. So I see that it is this diagonal line going across quadrant 1 and quadrant 3. So this is equation y equals x, which is the same thing as x equals y. Okay, so my first example, we want to reflect over the line y equals x, the point 3, negative 1. So over 3, down 1. So here's A. So now to find A prime, I want to flip it over. Now if I flip it over, I'm not really sure exactly where that's going to go, but I can kind of see if I flip it over, it's going to I'm trying to fold over that line, it's going to go right to here. All right, so it's kind of difficult to do, but this is A prime. And let's see, what is that point? It is now -1, comma 3. So let's see, what happened to our x and our y's to get to that image? Well, all we did is we switched them. So this is going to be the one example where I'm going to ask you to memorize this rule. When you reflect over the line x equals y or y equals x, all we're doing is we're switching the x and the y. So I'm going to have you highlight this one. This is the only one I want you to memorize because it's very difficult to graph this one out. Okay, so now let's go ahead and try the next example. So a reflection over the line x equals y. So instead of graphing it, I'm going to go to my rule. So we are going to switch the x and the y. So that I'm going to write the y first. So it's going to become 2 and -4. And we've got it. Okay, last but not least, a reflection over any other line. So our example, we want to reflect over the line x equals 2. So the first thing I have to do is draw x equals 2. Now my calculator cannot draw x equals, but it can draw y equals. So I'm going to type in y equals 2 and hit graph. And I notice that it's a horizontal line. So if y equals 2 goes side to side, x equals 2 is going to go up and down. So I'm going to go over 2, and I'm going to draw my line, x equals 2. Now I'm going to plot my point. So I'm starting with the point 3, -1. So here's my A. Now I want to plot its image. So again, we're going to flip it over this line. So I need to keep the distance the same. So I go over 1. So my image is also going to be over 1. And here is A prime. And that is the point 1, -1. Okay, and then we have the point -4, 2. So over -4 up 2, here's B. So let's see, we need to make sure we go the same distance on the other side. So I am 1, 2, 3, 4, 5, I am 6 units away, which means I also have to go 6 units away on the other side. 1, 2, 3, 4, 5, 6, there it is. So let's see, how far over are we? We're 1, 2, 3, 4, 5, 6, 7, 8. So we're 8, comma 2. So for this one, you're always just going to use the counting method. So you're just going to count how far away you are, and you're going to put the equivalent distance on the other side. All right, we've got one final task for today. So let's flip it over. And now we're going to go ahead and find the rigid motion. So if we take a look at this picture here, given the two triangles, state the rigid motion that will map triangle ABC onto triangle A prime, B prime, C prime. So if we take a look here, what's happening? Does everybody see how we're just flipping it over? All right, so now what you have to do is figure out where is your line of symmetry. And if I look carefully, it's going to be in the middle. So here's my line of symmetry right here. So now we have to figure out, well, what is that equation? Well, that is the equation 1, 2, 3. It's going up and down, so it's x equals 3. So now if we want to write the equation of this, or the rigid motion, this is a reflection, so we put in lowercase r. In subscript, we write the line x equals 3. And we are starting with the triangle ABC, that's our pre-image, and it's becoming triangle A prime, B prime, C prime. So we want to practice putting it in its original notation. Okay, and then our final question here, is triangle ABC congruent to triangle A prime, B prime, C prime? Well, let's take a look. Are they the same? And the answer here is yes. Now to explain it, we're going to say because reflections preserve side measure and angle measure. All right, this is where we are going to stop today, and I'm going to have you use the rest of your class now to practice your homework. If you have any questions, I will be back again tomorrow to answer those, but for right now, help each other out as best as you can. But very nice job today with your reflections.